Assalamu alaikum. I'm Hassan Maruf Ahmed Fahim. I am a fourth year student of CSE at Kumila University. Today I'll be giving a presentation on neural network. Before going into depth of neural network, we should first understand what is a neural network. Traditional machine learning models are bound by some predefined rules and they need to be fine-tuned for specific features, which is a hassle. We need a model that can identify patterns and make decisions directly from data without any predefined rules. And the inspiration for this model came from the structure of a human brain, which at an instance takes several data and makes decisions based on those data. Neuron is the fundamental unit of the nervous system. Taking it as an inspiration, in 1943, Warren McCulloch and Walter Pitts first created an artificial neuron. This model was a mathematical abstraction designed to mimic the basic operation of a biological neuron. Now, considering all this, the definition of neural network should be neural network is a computational model inspired by the human brain that consists of layers of interconnected nodes or neurons that can learn patterns from data and make decisions. Neural networks are used in areas like image recognition, language translation, and even in medical diagnosis. A typical neural network has three types of layers. The first, an input layer that receives the data, is input neuron in the layer corresponds to a feature in the input data. The- And the second, hidden layers. One or more hidden layers where the processing happens. A neural network can have one or multiple hidden layers. Each layer the consists of units that transform the inputs into something that the output layer can use, and an output layer that gives the final prediction. The learning in neural networks follows a structured three-stage process. The first, input computation. Data is fed into the network. The second, output generation. Based on the current parameters, the network generates an output. And the last, iterative refinements. The network refines its output by adjusting the weights and the biases, gradually improving its performance on diverse tasks. Now let's see how a neural network actually works. The first concept is forward propagation. We can also call it forward pass. When data is input into the network, it passes through the network in the forward direction, from the input layer through the hidden layers and to the output layer. This process is known as forward propagation. Two things happen during this phase. First, the linear transformation, which is the sum of inputs from each layer multiplied the weight associated with each of them. And the second is activation function. Now, the activation functions introduce non-linearity into the network, helping it learn complex patterns. Some of the popular activation functions are ReLU, sigmoid, and tanh. There are many variations to these activation functions. For example, a popular variation of ReLU is leaky ReLU, which prevents the dying neuron problem. Now that is a problem of another day. Now, the second concept is back propagation. After forward propagation, the network evaluates its performance using a loss functions, which measures the differences between the actual output and the predicted output. In order to minimize this loss, the model goes back in the network and based on gradient calculation updates the weights. And last stage is iteration. This process of forward propagation, loss calculation, backward propagation, and weight updates are repeated for many iterations over the dataset. Over time, this iterative process reduces the loss and the network's predictions become more accurate. Now we'll be talking about the advantages of neural network. The first advantage is ability to learn complex patterns. Neural networks can model and recognize very complicated relationships in data. The second, flexibility. They can be used for classification, regression, translation, image generation, and more. And the third is no need for manual feature engineering. Neural networks automatically learn important features from raw data. The fourth, high accuracy. When trained properly, they can outperform traditional algorithms, especially on large datasets. And the five, scalability. Neural networks can be scaled for handling large and complex problems. Now, the disadvantages of neural networks. The first is the neural networks requires large amounts of data. Uh, uh, Computation. The second, computational expensive. Training deep networks need powerful hardware like GPUs and a lot of time. The third is black box nature. It's hard to understand exactly how the network is making decisions. And the fourth is risk of overfitting. Networks can memorize data. Networks can memorize training data instead of generalizing to a new unseen data. The fifth is difficult to tune. Choosing the right architecture, learning rate, activation function, etc. can be very tricky and it requires experience. Now, thanks for sticking with me till the end, and with this, I am ending my presentation on neural network. Thank you.